Aviation is facing an unprecedented challenge. Within the coming decades, we need to completely overhaul how we power our aircraft. Moving away from fossil fuels will require the development of new materials and structures, and many people around the world are working on making these a reality. But regardless of which concepts are selected for our future aircraft, one thing is certain: they will require certification. If you can't certify it, you can't fly it. Now you might say, we already know how to do certification. We have a tried and trusted building block approach, where we start by qualifying materials, then we move up to structural elements, and eventually we end up at full-scale structures. But this approach is going to become too cumbersome to use in future. Why? Well, if you look at ongoing developments, what you see is that the distinction between structures and materials is blurring. Think, for example, of additive manufacturing, where you make your part and your material at the same time. And the part's microstructure will depend on details such as where on the build plate you made your part and what other parts you are making at the same time. Think of optimized layups and advanced fibre placement, where you continuously vary your fibre orientation, effectively creating hundreds or thousands of different layups in a single structure. Think of architectured microstructures, where we intentionally vary the microstructure throughout the part. Or think of natural fibres, where the properties vary from batch to batch and from growing season to growing season, almost giving you a different material each time. If you want to certify these concepts with the building block approach, then you effectively have hundreds or thousands of materials per part, which you would have to qualify individually. Now obviously that will take far too much time and effort. We saw this problem before when we introduced composites and fibre metal laminates. There we solved the issue by standardization, limiting designers to a small menu of qualified layups. Certification was achieved, but in retrospect we can see it came at the cost of design freedom. If we want that freedom back, to profit from emerging material and structure technologies, then we need a different approach. The solution is to certify based on the performance of what is actually built. And there are three pillars to the smarter certification approach. The first is to have an understanding of the underlying constitutive behavior of the material and of defects in the material. Secondly, we need to use sensors and process monitoring to understand what the state is of the parts that we have actually built. What microstructures and defects do they contain? With this information, we can subject the parts to the third pillar, virtual testing, to understand the performance not just of a sample from a batch of parts, but of each individual part that we have built, so we can be assured that it meets the requirements. To sum up, the distinction between material and structure is blurring. And the solution is to use physics, process monitoring, and simulation-based acceptance to understand the performance of the part as built. By adopting this new certification approach, we can reduce the time and cost to certify new parts and materials and ensure they are available when we need them. My name is John Pesco. I'm an assistant professor at the Faculty of Aerospace Engineering of TU Delft. And if you have any questions, feedback, or would like to collaborate, please get in touch and let's build a more sustainable aviation industry together.